All right, so here we go. So a relation is simply a pairing from one set to another. Like say I had a deck of cards and I give a card or two to Janessa, and I give a card or two to Ava, and I give a couple cards to Jason, whatever. And so like say the ace of diamonds goes to Janessa, and the 10 of hearts goes to Janessa, and the ace of spades goes to Ava, and then the 2 of clubs goes to Jason. That would be what we call a relation. It's just relating one set to another. Okay? And we tend to write these in ordered pairs. So, like for instance, 3 of hearts goes to Jason. 3 of hearts, comma Jason. It's relating two sets between each other. Okay. The X's are the inputs. The Y's are the outputs. All right. The set of the inputs is called the domain. You've heard this word before. It's the domain of the relation. And the set of the outputs is called the range. So in the example that I'm talking about where I'm giving cards to people, okay, like if the 4 of diamonds goes to Jolie, the 4 of diamonds is a domain value and Jolie would be a range value. Okay, that's how that works. This is not a function yet because there's a special rule that functions have to abide by to no longer just be a relation, but also a function. Functions are relations, but not all relations are functions. Okay? Functions are special relations that we'll talk about here shortly. Any questions about these ideas? The set of the x's are called the domain. The set of the y's are called the range. Domain and range. That's what you've heard of before in the past, I'm sure. Certainly in Algebra 2, we talked about domain and range. Question on this?
So you said X is domain and
X is domain. Think about, put it in alphabetical order. Domain comes before range.
Okay.
Domain is the x's, range is the y's. All right, so here we go. Couple quick examples. In this case, don't even write this down. Okay, let's pretend on your phone the numbers have letters attached to them. Okay, so the number 2 has A, B, and C. Correct. And like when texting started, if you wanted to dial, have the letter B, you had to hit 2 twice before keyboards showed up on phones. Do you remember those days?
Yeah.
You had to hit 2, 3 times to type a C. Classic. Okay. And then they invented the slide phone, the keyboard, like boom.
I remember my mom got one. I was like,
physical buttons. Physical buttons. So we would say here that 2 goes to A, 2 goes to B, and 2 goes to C. This would be a relation. Okay, we're relating numbers to letters in this case. The input, well, the only domain value is 2. All right. Now there are 3 range values. The range values would be A, B, and C. Those would be the range values. Okay. So the domain's the x's, the range is the y's. In this case, only one input, the number 2. For the, we only picked number 2. We could have done the others, of course. But then the range values, the outputs would have been A, B, and C. Does that make sense? Okay. Easy. All right, so let's do this real quick. And again, don't even write it down. Let's just kind of plow through it. Let's pretend we have these ordered pairs. Here's the answers. Say we had these ordered pairs. Okay, and this is all we have. We're relating numbers to numbers. 100 goes to 5. 120 goes to 5, 140 goes to 6, 160 goes to 6, and 180 goes to 12. Okay? The domain is just the set of the x's. And the range is just the set of the y's. And in this case, it's just 5, 6, and 12. You would it would be weird if you wrote range. We would not do this. Even though 5 shows up twice and 6 shows up twice, you would not do that. Okay, you just say 5, 6, and 12. That's it. Don't write the 5 twice. Okay. So again, domain's the set of the x's, range is the set of the y's. That's it. All right. Easy idea. There's probably way too many slides on this for the slight difficulty of the concept. Concept is very simple. Okay. Questions about domain range? All right, so we're talking about relations, right? Now, in this case, we actually have dots. negative 2, 2, negative 1, 1, 0, 0, 1, negative 1, 2, negative 2, 3, negative 3, etc. Again, nothing's different. The x's were first. That's my domain. Negative 2, negative 1, 0, 1, 2, and 3. Okay? And then the range is the y's, 2, 1, 0, negative 1, negative 2, negative 3, which then they're all right there. Okay? So domain is the x's, range is the y's. The x's are what's getting sent to the y's. Okay? In this case, negative 2 is getting sent to 2. Negative 1 is getting sent to 1. 0 is getting sent to 0, and so on and so forth. Okay? Am I making sense? Easy. Easy. Okay. Well, let's slow it down a little bit now. Okay? Because here's where life starts to get a little more complicated. A function is a relation with the rule that each x gets exactly one y. Okay? Think about that button example. 2 went to A, 2 went to B, and 2 went to C. That relation is not a function, right? Because if we wrote them as points, 2 goes to A, 2 goes to B, 2 goes to C, you have the same x value going to multiple y's. That is not allowed. Okay? So if we're going to start talking about are these relations functions, you have to ask, does each x get exactly one y? Does every element in the domain have exactly one y in the range? Okay. Now, those x's can all go to the same y. That's fine. Each y doesn't have to have exactly one x, but each x has to have exactly one y. So if I have the deck of cards, all right, and I give one card to Janessa, and one card to Ava, and one card to Jason, and one card to Dean, and one card to Slates, and one card to King, etc. All right. As long as I only count the cards that I handed out, that would be a function. Okay? If the ace of spades doesn't get passed out, then it's not a function. If you count the ace of spades as being part of the domain, every x has to get exactly one y. It can't go to no y's. It can't go to two y's. Right? Every x has to get exactly one y. Am I making sense? Okay. So, are these relations functions? Okay. As long as you understand the idea, it doesn't really matter. Okay. Let's see. Let's talk about this real quick. Let's pretend that we're creating a relation, and it's items getting sent to their prices at a store. Okay. Like orange juice, $1.99. Box of Cinnamon Toast Crunch, $3.49 on a certain day. Okay. Would you say that this relation from items to prices, would you say that that's a function? Yeah, on a given day. Like, of course, over time, prices are going to change. But on a certain day, this would be a function, right? The orange juice, the Tropicana whatever, with no pulp, is $2.50. And it's going to be $2.50 that day for the entire day. All right. Now, if we're living in a world of like hyperinflation, where it's $2.50 in the morning, but then $3.50 in the afternoon, now we got a problem. But that's generally not how stores work. Okay. On a given day, a certain item has a certain price. So this would be a function. Okay. The Cocoa Pebbles cost $3.29. All right. So this would be a function because each x gets exactly one y. Am I making sense? Now let's flip it. Types of fruit getting sent to the color of that fruit.
No.
Type of fruit x's to color of that fruit. Why not?
Because there's more than one fruit that's each color.
Give me an example.
So
it's type of fruit to the color of that fruit.
like strawberries and And like apples?
Can strawberries go to red and apples go to red? Is that okay?
No.
That is okay. A y can have multiple x's. The x's can only have one y. Okay. So if you
so
say
if it said colors to fruit, then it wouldn't work.
yes, exactly right. If you said color of the fruit to the fruit, then that would not be a function. Is fruit to colors a function? Yes.
Is fruits X and then colors is Y?
Yes. Fruits x, colors y. So is fruits to colors a function?
Yes.
What color are apples?
You're confusing me.
Green.
Green, yellow, right? Can't apples get sent to green?
Pineapples and bananas.
Say that one more time.
Pineapples and bananas.
Oh, like they're different colors?
But they're the same color.
That is irrelevant that they're the same color. The question is, can a fruit have two different colors, right? Because we're talking about the fruit is the X and the color is the Y, right? So there is no problem with apples being red and strawberries being red, right? That is no issue. That's okay. But you can't have apples being green and apples being yellow. Do you see the difference? That's the problem. Y's can have multiple X's, okay? But X's can't have multiple Y's, all right? So you can't have apple green and apple red. That makes this not a function.
So is a Y always going to be constant?
What do you mean by that?
Like, is it in one problem? Is it going to be the same throughout all of the groups?
It can be, but it usually will not be.
Is there a constant at all for all of them, or is it like?
It depends on the function. You can have, you see the horizontal line? Think about the line y equals 2. 1 gets sent to 2, 2 gets sent to 2, 3 gets sent to 2, 4 gets sent to 2. That is a function. You can have infinitely many x's going to the same y. You just can't have the same x going to two different y's. Right? Each x gets one y, and that doesn't mean that each y gets one x. Slates.
Is like the question gonna be like that broad on like the quiz? Because like I mean you just
It'll
like,
probably
fruit,
be numerical.
or is it gonna be like apples
Probably
their color?
numerical. Probably.
Okay, good.
Oh, wait.
So since it's like multiple fruits, it would have to be just one, right? For it to be like,
For it to be yes, or would it have to be? Would it just be the opposite of color?
For this to be a function from fruits to colors, you could not have a fruit that has multiple colors.
Okay, but if it was the opposite colors to fruits.
That would still be no, because red goes to strawberry, but red also goes to apple.
Okay.
That would still not be a function. Yeah. But here, when I asked, is this a function, people correctly said no, but they gave me a wrong justification. Right? Their answer was correct, but the justification was wrong. If you say no, this is not a function because strawberries are red and apples are red, that's not a correct
Do you
justification.
have to give an explanation on the test?
I guess it depends. Wait till the practice quiz. I'll give you the practice quiz on Wednesday. Don't panic. Probably numerical.
We're one slide in.
Yeah. Okay. So here we go. For function notation, what we do here is we call this on the left-hand side f of x. The function is f. All right. When we have a function, we use function notation. X is my input. F of x is the output for that x. Okay. So if I say, for instance, f of x equals 5x plus 3, what that means is no matter what you input in for x, you're going to multiply it by 5 and then add 3. F of x equals 5x plus 3 means whatever you put in for x, you're going to multiply it by 5 and add 3, and that's going to be the number it's related to. Okay? So for instance, in this case, f of 1 is 8, right? Because I plug a 1 in here. 5 times 1 is 5, plus 3 is 8. So I would say 1 goes to 8. 1 is the domain value. 8 is the range value. Okay? And notice, this is a function. Can you think about an x value that would give me two different answers for 5x plus 3? Like if I plug in 2, am I going to get like 17 one time and 24 another time? No. Every x is going to have its own y. Okay. So no problem there. When you see like a plus or minus, maybe that's going to be an issue. But in this case, 5x plus 3, definitely a function. No matter what x you plug in, you're only going to get one y out. Okay. So this is the notation that we use. Each x gets one y. When we have a function, when we have a relation that's also a function, we use this notation here to describe what is going on and what does this function do? What's the pattern that it follows? Okay. Where does it take 2? Well, what's f of 2? 5 times 2 plus 3 is 13. So that means that 2 goes to 13. Okay, that's the idea. It's a relation, but it's stronger than a relation. It's a function. And when it's a function, we can use function notation. F of 1 is 8. F of 2 is 13. That means when I plug in 1, I get 8 out. When I plug in 2, I get 13 out. Etc. Okay. Questions on function notation so far? Functions. Each x gets exactly one y. Each x. In a relation, that's not the rule. But for a function, each x can only get one y. Okay. All right, here we go. So let's look at these and figure out, are they functions or are they not? Look at that first set of points. 2, 3, 4, 1, and 4, 5. Not a very interesting set of points. Okay. Is that right there a function? Why not?
2 4s go to.
Because 2 4s, right? 4 goes to 1 and 4 goes to 5. This is a no. Right? Now, could 1 go to 4 and 5 go to 4? Is that okay? What if I asked this question? Is that a function in green?
Yes.
Yes. Do you see the difference? Y's being repeated is okay. X is being repeated, not okay. All right. The fact that 4 goes to 1 and 4 goes to 5, that tells you that we do not have a function. If 2 goes to 4 and 3 goes to 4, that's fine. That's not a problem at all. See the difference? Making sense? How about the next one? 3x plus y equals 1. Does that look like a function to you? Let's isolate the y. How would I get y by itself? Subtract 3x? Okay. Imagine plugging in a value of x. Are you ever going to get multiple answers for y? Like if you plug in x equals 10, are you going to get two different answers for y? No. Is this a function? Yes, it is. This is a function. Okay. Every x is going to get exactly one y. And you see that when you isolate the y, if there's not like a plus or minus weirdness here, it's going to be a function. Okay. Now here's where it gets interesting.
Wait,
Negative-
hold on.
Yes, go ahead.
I'm confused how you can tell from that.
Okay, so imagine plugging in a value for x.
Okay.
An individual, like 10.
Any number.
What's 3 times 10?
30.
What's 1 minus 30?
29.
Negative 29, right?
Negative
If you plug in 10 again, are you going to get a different value?
29. No.
Doesn't 10 just go to negative 29 and that's it?
Yeah.
That's how every number acts. No matter what number you give me, you're going to multiply it by 3. And you're
Then when would it be no? Oh.
okay? That's where I'm pushing the buttons,
Oh.
okay? How are you going to isolate y here? Let's add 4x squared. Now, we don't have y by itself yet. What do I have to do? Square root. What happens on the right-hand side? And so what do we do when we take the square root of both sides? What happens on the right? If x squared equals 9, what does x have to be? Either or, it's the plus or minus, right? So looky, if I take the square root of both sides, I get y equals plus or minus radical 9 plus 4x squared. Now, if I plug in x equals 0, how many different y's am I going to get? 2, right? Because if I take x equals 0, it's the square root of 9, which is 3. But it'll be plus 3 or minus 3. 0 goes to positive 3, but it also goes to negative 3, which means this is not a function. Miss Austin.
Wait, why are we doing plus or minus?
Because think about it. Make a different one. Square root both sides, right?
Okay.
Is this correct?
Yeah.
No, it's not.
Oh. No.
Isn't negative 3 squared also 9?
Oh, okay.
You need to say plus or minus. Same thing here. We did the square root of both sides.
How did you know that though?
How did I know what?
Like, how do you know to do that?
Because it's x whenever. Okay,
Because it's not.
Okay. okay, looky. Here's the theory behind the plus or minus. Okay?
I get it over there, but why? Like, how
Well,
do you?
if you get it over here, you get it over here.
It's like an equation though. Like, there's like
This is an equation.
plus 4x.
This is an equation, right? Take a square root of both sides. Really, the square root of 9 is 3. Square root means positive square root. Square root of 25 is 5, square root of 36 is 6. Okay. The plus or minus actually shows up from the left-hand side. This is actually an alternative definition of absolute value of x. Think about it. If I plug in 4 for x, what's 4 squared?
16.
And what's the square root of 16?
30.
Square root of 16.
Oh.
4. I plugged in
square
4 and I
root.
got 4 out, right? Now, what's negative 4 squared?
The same thing.
16. And what's the square root of 16? 4.
Yeah.
I plug in 4, I get 4 out. I plug in negative 4 and I still get 4 out. This is actually the absolute, we've just described an absolute value,
Okay.
right? If I plug in negative 5, it gives me positive 5, that's an absolute value. Well, if absolute x is 3, doesn't that mean x is plus or minus 3?
Yeah.
Same thing here. It's just more complicated.
So we just always have plus or minus.
Yes, when you're taking the square root of both sides.
Okay.
Yes. Yes. So now notice, in this case, 0 would get mapped to 3, but it would also get mapped to negative 3. Okay? Once you see this plus or minus show up, bad news. Probably not a function. Okay? Almost definitely not a function for our intents and purposes. Okay? Whereas for question B, we didn't have the plus or minus stuff. We just said 3 times x, and then 1 minus that. Each x is only going to give you 1 y, not for C. For instance, 0 goes to 3, but 0 also goes to negative 3. Okay. Making sense? Got to be careful on that. Questions? So if it gives you something in terms of x's and y's, isolate the y. If you don't get a plus or minus business, you're probably okay. All right? Questions? All right. Now, let's find some domains here. Now, when we say find the domain, we're saying in the real world, what real numbers make sense here? Okay. The first one is a function of t. Yes, ma'am.
Can you search?
Yes. The first one's a function of t. The function is called capital G, and t is my independent variable. Okay. And we want to know what's the domain of this function. Well, what value of t gives us a problem in question A? What can t not be? T can't be 4. You agree with that? T cannot be 4. Because now you make the denominator 0, and life is bad. So here, if we said what's the domain, t can't be 4. Okay? If you wanted to write it in interval notation, you'd say negative infinity to 4, union 4 to infinity. It's a really, really, really fancy way of saying not 4. Really, really fancy way, okay, of saying not 4. Negative infinity to 4, union 4 to infinity. How about the one on the right? A little more difficult, maybe a little different. What do we know about being underneath a square root sign? Can't be negative, right? Can you be 0? What's the square root of 0? 0. And anything positive is okay. But if x plus 1 is negative, this function gives us a problem, right? Because you can't take the square root of a negative number. So what we're going to do here, we're going to say that x plus 1 has to be greater than or equal to 0. Does that make sense? If x plus 1 is negative, the square root of a negative number does not make sense. We're not talking about complex numbers here, we're just talking about real numbers. Okay. So what are you going to do here to get x by itself? Yeah, subtract 1. So x has to be greater than or equal to -1. Or, of course, if we wanted to write it in fancy schmancy interval notation, it would be square bracket -1 comma infinity. Round parenthesis. Okay. So watch out for domain questions. If they give you a fraction, you have to make sure the denominator isn't 0. If they give you a square root, you have to make sure whatever's under the square root has to be greater than or equal to 0. Okay. That's what you gotta watch out for. Those are the two main things. Whenever you have a fraction, you have to make sure the denominator isn't 0. You can't divide by 0, right? So like in this case, if this were something more complicated, like if t minus 4 were more complicated, just set that equal to 0 and figure out what values make this down there 0. But in this case, it's just t minus 4 equals 0, so t is 4. Here, underneath the square root, you have to make sure this is greater than or equal to 0. Whatever's under that square root, make sure it's not negative. Solve the inequality and then figure out where your domain is. Questions on that? Finding domains? Okay. Let's evaluate some functions. Just a couple more slides, I think. This one, and then this one. Yeah, then piecewise, and then we get. Okay. So look at the function here. F of x equals 8 plus 4x. That means whatever your x is, you're going to multiply it by 4 and then add 8 to it. That's what it means. Okay. So what's f of 0 going to be? Where does this function take 0? 0 must be related to something. Where does 0 go? Colton, what do you think?
The 0 is your x, right?
Yeah, 0 is my x. So what's 8 plus 4x?
8 plus 4 times 0.
Which is?
8.
Exactly. So what point would have to be on that graph?
8.
Well, give me an x and a y.
8, 0.
Now.
0, 8.
0, 8, right? Isn't 0, 8 on this graph somewhere? Okay. X is 0, y is 8, so 0, 8 is on the graph. Pickens, how about f of 1/2? What does that mean? It means 8 plus 4 times 1/2. What is 4 times 1/2? It's half of 4. Yes.
2.
2 plus 8 is?
10.
Yep. So what is a point on that graph, Miss Pickens? What comma what? The first one was 0 comma 8.
1/2.
Comma
10.
10. Yeah, 1/2 comma 10 is on this graph. Okay. It satisfies the function. When you plug in 1/2, you get 10 out. 1/2 goes in, 10 goes out, so 1/2 10 is on the graph. How about f of -2? Miss Martin, what do you think?
It'd be 8 plus 4 times -2.
Yep, which is
0.
0. So -2 goes to 0. 0 goes to 8, but -2 goes to 0. That's fine. There's nothing wrong with that. Okay. Do you agree no matter what x you plug in, you're going to get exactly one y? Right? Like if I plug in 17.2, I'm not going to get 4 different y's, right? Each x will get exactly one y. Okay. Questions on the evaluations? All right. Well, graphically speaking, say this is some weird graph, weird function. Okay. What would f of 0 have to be? If this were my graph, what does 0 have to get sent to? Lucius. You're right. 3. Why do you know it's 3?
Because of the graph.
Yeah, because the graph. 0, 3 is right here. And it's on the graph. So f of 0 must be 3. Okay. 11 good. How about f of 1/2?
1.5? Oh, 0.5.
Just 0.
What's the y value for x being 1/2?
Oh, 0.
0, correct, right? 1/2 comma 0 is the point on the graph. And Lane, what's f of -2?
4.
Yep, right up here. Okay, makes sense? The 0, the 1/2, and the -2 are domain values. The 3, the 0, and the 4 are range values. See the difference? And each x gets exactly 1 y. So it is a function. So using function notation makes sense. Questions on this one? One more idea. Piecewise defined functions. Okay, and then I think we're done. Yeah. So let's talk about these real quick. Sometimes different functions follow different rules for different values of x. Okay. Like here's a real life example. Say you're going to buy, T-shirts for something, and the company says the first 10 T-shirts you buy are $20 each. But if you buy more than 10, they only cost $10 each. Okay, so you'd have a line with a slope of 20 first, and then you'd have a line with a slope of 10 after. Okay, this is actually a real life thing that happens all the time. Now, if you're going to go buy gas somewhere, this would not be piecewise defined. Okay, if you buy 1 gallon, well, went on the way home yesterday, it was $3.35 at most places. Okay, that's for the birds. 1 gallon costs you $3.35, 2 gallons cost you $7.70, etc. And you're going to have a perfect straight line moving upward to the slope of $3.35. Okay, this guy, maybe there's a reason why it would act different in different locations. Okay, to the left of 0, it looks like a linear 2x plus 1. But if you get to 0 or beyond, it looks like a quadratic. Well, the graph would look weird, but we're not asking you to graph it. We're just asking you to find these functional values. Okay? What would f of 0 be in this case? If this function is defined piecewise for two different sets of x, there's x is less than 0, there's x is greater than or equal to 0. Which one will f of 0 follow? Does it follow the top rule or does it follow the bottom rule? Follows the bottom rule, right? Because 0 is greater than or equal to 0. So what's f of 0 going to be then? 0. It's going to be 0 squared. Notice we're following the bottom rule because the x is inside of that region. 0 is greater than or equal to 0, so you follow the bottom piecewise defined part. Okay. Whereas if I say f of 5, which one am I going to follow this time? Still the bottom one, right? Because 5 is greater than or equal to 0. So now f of 5 is going to be 25. But how about f of -2? Now you're going to follow the top one. Right. Did you guys do these in Algebra 2? Piecewise defined? A little bit. So f of -2, now you're going to follow this rule.
How do you know which one's gonna follow?
Because it says the x is less than 0.
Okay.
Isn't x less than 0?
Yeah.
But for 0 and 5, it was greater than or equal to 0.
Okay, got it.
Okay. So now it's 2 times -2 plus 1, which is -3, I guess. So 0 and 5 follow the second rule, whereas -2 follows the top rule. And we call these piecewise defined functions. It will be in the homework a little bit for you. questions or concerns for me? So relations relate one set to another. A function is a special relation where each x gets exactly one y. And if we have a function, we use function notation. F of x equals whatever. X's are your domain values, y's are your range values. Okay.
Can you go back to a few slides? It's like finding the domain.
Yes.
I don't understand.
This one?
Yeah. I don't understand. Can you go again?
Well, okay. So domain means what's the set of x's, well, in this case, t's. What's the set of t's that makes sense? Like, what t values can I plug into this? Do you agree that g of 4 makes absolutely no sense?
Because it makes it 0?
It makes it down. Right. If I say g of 4, doesn't it have to be 1 over 4 minus 4? I almost like cringed even writing it. What's 4 minus 4?
0.
What's 1 divided by 0?
0.
No! That's 0 divided by 1.
Oh.
1 divided by 0 is undefined.
Oh.
This doesn't make any sense.
Yeah.
I mean, like, my blood is curdling right now.
Hey,
I just wrote 1 divided by 0. This is bad. This doesn't make any sense. 4 doesn't go inside of this function because it makes the denominator 0.
Yeah.
Okay. Now, look at the square. Now, the square root's different. If you're underneath the square root, you better be non-negative.
Yeah.
You could be 0 or positive. If I plug in negative 10 here, what's negative 10 plus 1?
-9.
And what's the square root of negative 9? Doesn't make any sense, right? We know it's like, 3i or whatever, but
Yeah.
we're not talking about complex numbers, we're talking about real numbers. So we have to make sure that this x plus 1 is at least 0. Okay? Subtract 1 from both sides, x is greater than or equal to -1, and then this is just running it in interval notation.
Wait, I'm just confused how you knew how to write it like that. Like x minus 1 is greater than, like, where did that come from?
This?
Yeah.
I just subtracted 1 from both sides. This is x plus 1 is left greater than or equal to 0, subtract 1.
Oh, no. No, I get that. I get that part. I get
Okay.
that part. You just, like, okay. Wait, did you
I just solved the inequality.
take off the square root?
Well, I'm saying for this to be defined, for this to make sense, it better be a positive or 0.
Yeah.
If it's negative, it's out. Just like 4 was out,
Okay.
right? So I'm making sure, so I'm figuring out, well, where is x plus 1 greater than or equal to 0? So set up that inequality. X plus 1 greater than or equal to 0, subtract 1. Oh, as long as I'm greater than or equal to -1, I'm fine. Look at, what's -1 plus 1?
0.
It makes sense. What's 0 plus 1?
1.
1, it makes sense. What's 1 plus 1? 2, that makes sense. What's -5 plus 1?
-4.
That doesn't make sense. So this guy here tells us the rules on x, which make the square root of x plus 1 defined.
Okay.
I'm not trying to figure out what the y's are. I'm just saying when does this actually make sense? X has to be greater than or equal to 1.
Okay.
And then here x can't be 4.
Okay.
Think about it.
I'm trying.
Questions? All right, here is your homework. 3 to 36 by 3s. I'll go ahead and post that assignment for you. That's all I got. A little more notes than usual. We made it through. Most of the ideas weren't too bad. If you have any questions on the homework, I'll answer those tomorrow, of course.